just quickly want to go over the question 10 on page 68 that we did the other day. Just a brief recap of what it was about. The half-life of uranium-235 is 704 million years. And then it explained that obviously that means that it takes 704 million years for there to be half the original amount left. And then the question was, how long does it take the radioactivity of uranium, blah, 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 to reduce by 10%? And we were wondering, how did we get the a half to the power of t over 704 million years? And that was because I had used a physics formula. How do we get that formula is what I want to show you today. So basically, I'm going to use AO as my original amount. We know that my formula for finding a reduction would be the original amount multiplied by some amount that it's reducing by, which we don't know what it is in this case. We don't know what the original amount was either. But I do know that it takes 704 million years for that to be half of the original amount. Okay, so we know that it takes 704 million years, so t in this case is 704 million. The x is the amount that it's reducing by each time, and we have our original amounts. Now again, we've got an original amount on each side. Because it's on each side, that means I can divide both sides by original amount, so I don't need to worry about that. So to find what the amount it's reducing by was, I just need to 704th root both sides, so I get a half to the 1 over 704. That is the amount it's reducing by. I now can work out what my actual question is asking. It's saying how long to reduce by 10%. So if it's reduced by 10%, that means that I've got 9/10 left. Remember, it's 1 minus the 10% will give you how much of the original we're trying to find. So I'm looking, it'll be 9/10 of my original amount is equal to the amount it's reducing by, this x, which is a half, to the 1 over 704 million t. And that's how we got that equation that we started with of the original amount again. So we again can delete that. Now just look back to questions, any of the other questions, you'll always see it's the original amount times by 1 plus or minus that amount over there to the t. So that's what we're working with, and that's what we have over there. Okay, so that's that. So again, now we're just going to do what I did the last time. We need to take the log of both sides. So are you happy that this is equal to 9/10 is equal to, if you having something in a bracket to the power, you multiply those, so that's going to be t over 704 million, which we had, and this is the bit that we actually did the other day, so I'm just going to do it in a different color. So we're going to take the log of both sides, to the power of, that means that can come down the front. And then I can just divide both sides by log a half. And then multiply up by 704 million. So equals the time. And that gives us the correct answer. I'm not going to put that in my calculator. You can do that, and it should give you the correct answer. Please come and see me if you are unsure about any of that or want to know about it. It actually wasn't that difficult. It was just thinking about what we're doing. So you did not need to know some random formula. You just needed to apply what we knew already. Awesome. Thanks for watching.